So for those of you who were not in class with us for this lesson, for 6.8, this is what we did. We were looking at two special triangles that we find in mathematics, two special right triangles. And this one is the isosceles right triangle. We often call it a 45, 45, 90. Okay, so you'll hear this a lot. And this is a special type of triangle. So what I'm going to just show you is the pattern that happens each time. Okay, so let's say the length of the leg is 1. If this is a right triangle, the length of in its isosceles, then this length will also be 1. And if I want to figure out what this side is, I'll have to set up the Pythagorean theorem. So 1 squared plus 1 squared is going to be c squared. And if I take the square root of both sides, I see that the square root of 2 will be c. So this leg is going to be the square root of 2. And if I do the same thing again for, let's go with 3 as our leg. So if we have 3 and 3, what will this be? So I'll use the Pythagorean theorem again. And then the square root of 18 will be c. However, we need to simplify this radical so that we can see the pattern that's happening. Okay, and so when you simplify this, you can think about that 18 is 9 and 2. Okay, and then so when you simplify this radical, you should be able to take out a 3. So it's going to be 3 root 2 is c. And if I do it with 5, you can do it with any of these numbers. And then I look for c. So we know that's going to be 25 and 25. So the square root of 50 is c squared, but is c. So if I want to find the pattern, though, I need to simplify this radical. So I can rewrite this as, we can simplify radicals in different ways. This is the same thing as square root 25 times the square root of 2. And I know the square root of 25 is just 5. So 5 root 2. And now, if you have a look, you can actually see the pattern that's taking place. So 3, and this is 3 root 2. 5, this is 5 root 2. 1, this is 1 root 2, because we know we can always write a 1 in front of any number and it doesn't change it. So that's the pattern that happens in a 45, 45, 90. What will always happen is the legs are the same because it's an isosceles triangle, and the hypotenuse will always be the length of the leg times the square root of 2. So I can just draw that out in a second once this. Okay, so the pattern that exists is, again, in any triangle with 45 degrees, 90 here, and 45 degrees, so a right isosceles triangle, whatever this leg is, this leg will be the same, and this third, the hypotenuse, will be whatever that x leg is times the square root of 2. Okay, so that's one of the special triangles that we're looking at. Another special triangle that we look at is an equilateral triangle. Okay, so if I have an equilateral triangle, and if I split it in half, okay, it will become a right. This is 60. This whole thing was 60. That means this piece is 30. And if I just look at this piece, this side, I'm going to do some work and look at some patterns here, okay? And then I'll show you how we get the other special triangle in math. So if this side let's just do an example. If this side were 4, if this side were 4, well, this side's also obviously 4, and this other long side is also 4, right? Because it's a equilateral triangle. If I take half of it, though, this side is going to be 2, right? And then now what I can do, I'm just going to look at this side. If I want to solve for the third leg, let's call it x, or let's just call it leg A. If I want to solve for the third leg, I can just use the Pythagorean theorem. So a squared plus 2 squared equals 4 squared, okay? So a is the square root of 12, but now I need to simplify that radical. Okay, so a couple different ways to simplify. I can do 2 times 6 and 2 times 3. I can build a factor tree, and then for each pair, I can take 1 out of the radical. Okay, so in this case, a is 2 square root of 3. And now if you continue to do that pattern over and over again, I can do one more pattern for you that you can look at that's on the table. If this is 60 and this is 30, okay. If this is 8, and this were a bigger triangle, right, or pretend that we've got a bigger triangle going on here, this side is going to be 4, okay, and then I can use the Pythagorean theorem to solve for this side. So a squared plus 4 squared is going to be 8 squared. Not 58, 48, sorry. And when we take numbers out, sorry, when we look at, when we try to simplify this radical, okay, we can split it up if we want. We can factor tree it. I know it's going to be 16 times 3, 4 and 4, 2 and 2. Okay, so for each pair, 1 can come outside of the radical, and I've got this left underneath. And so what I notice is a will be 4 times the square root of 3. Okay, so 4 times the square root of 3. So if you have a look at this, whatever this leg is, this leg, the longer leg, will always be that leg times the square root of 3. Do we see that? And this leg is always 2 times the other leg. So if we have a look here, again, whatever this leg is, the longer leg will be that number times the square root of 3. And the hypotenuse will be twice this longer leg. So the way we write that as a general rule is we can say, right, instead of using numbers now, let's use variables to make it a general rule. So whatever the short leg is, let's call it x. The hypotenuse was always 2 times the short leg, right? So the hypotenuse was always 2 times 2 is 4, or 2 times 4 is 8. And then the other leg was always that number of the short leg times the square root of 3. So it's always the number of the short leg times the square root of 3. Okay? And the way I memorize this is that the shortest leg is always across from 30, and that's always x. So I like to put the x first, and then the hypotenuse is 2x, and the long leg will always be x times the square root of 3. So if we just quickly look at two examples. Okay, so for example, if you have this triangle, if this leg is 5, this leg will also be 5, and this leg, without even having to do the Pythagorean theorem, you can already say is 5 square root of 2, because this is a 45, 45, 90 triangle, and that's the pattern that exists. If you're looking at this triangle, if the short leg, which is here, is 7, the hypotenuse will be 14, and the long leg will be 7 root 3. Okay, so that's just a pattern that will help you be able to solve more problems, right? Because now we can actually solve this if we only know one leg, right? So if you have a 30, 60, 90 triangle and you only know that this is 20, you can still solve the other sides. This one has to be 10, and this is going to be 10 root 3.